Hello friends, myself Dr. Nandakumar Raubale from College of Engineering Ambazugai is going to deal with Applied Thermodynamics 2. This is our 21st lecture. In previous lecture we have discussed about fossil fuels, petroleum products, tidal energy, nuclear fuels, then wind energy, tidal energy, geothermal energy and generally out of thermal power plant. Whereas the factors which are considered for selection of thermal power plant. So today we are going to discuss about the diesel power plant, advantages and disadvantages of diesel power plant. Then we are going to study gas turbine power plant and classification of gas turbine power plant, advantages and disadvantages of gas turbine power plant, then hydroelectric power plant, then classification of hydroelectric power plant, then advantages and disadvantages of hydroelectric power plant, then site selection for hydroelectric power plant. So now very first we are going to discuss about diesel power plants. So the diesel power plant is similar to the thermal power plant, only the kind of prime mover is used in diesel power plant is a diesel engine. So in steam power plant or thermal power plant, the steam turbine is used as a prime mover to convert heat energy into mechanical work. Here the diesel engine is used to convert heat energy into mechanical work. This is the major difference between steam power plant and diesel power plant. So this diesel power plant consists of a diesel engine. The shaft of a diesel engine rotated with the help of heat energy produced by combustion of diesel, and the shaft is connected to the generator or the electrical system which converts mechanical energy into electrical energy, and this electrical energy produced is transmitted through the transmission lines. So this is what a diesel power plant is. So now we will discuss about how this diesel power plant works. So let us consider diesel power plant, generally out of a diesel power plant. So here this is the main component of this diesel power plant is diesel engine. So this block represents diesel engine. Then this diesel engine requires air to run this diesel engine. So air filter is there. Through this air filter, so air is supplied to the engine. Then to run this engine, fuel is required. So fuel day tank is here. So from this fuel tank, the fuel pump supplies this diesel through the oil filter into the fuel injector to the diesel engine. So here the fuel which is supplied from fuel tank is first filtered, then with the help of fuel pump it is injected into the engine cylinder. So for combustion purpose air is required, so air is supplied from here. So for supercharging purpose, so compressed air is also required. So this compressed air is taken from this compressor, and the compressed air is filtered, and that is also supplied to the diesel engine. So now due to the combustion of fuel, so this heat energy produced is converted into mechanical work, and the shaft starts to rotate, and this shaft is connected to the generator which convert this mechanical energy into electrical energy, and this electrical energy is transmitted. So now the product of combustion, the exhaust gases are brought out and are sent into the atmosphere through the silencer or whatsoever we may call it as a chimney like device. So now for this diesel engine, so cooling system is required, as heat produced, part of heat produced is converted into mechanical work, but a large part of heat which is rejected. So in order to reject heat, so here the water is circulated through the water jacket, and the hot water comes out from this engine, and here is the surge tank. Then this water is passed into the condenser, where this water is cooled. Again the cooling pump or cold water is recirculated into the engine through this pump and oil cooler. So this hot water is circulated into this engine cylinder. So in this condenser the cold water is circulated, and this cold water is passed into the condenser to carry heat from the water coming out from diesel engine. So this water which comes out from diesel engine gives its heat into the condenser to the cooling water, and this cooling water is passed into the cooling tower, where this water is again cooled, and this cold water is recirculated into the condenser to carry out the heat rejected by the diesel engine. So this heat, after rejecting heat into the condenser, this water coming out of the diesel engine is cooled, and again it is recirculated to the engine as well as oil cooler. So another aspect of this diesel engine plant is lubrication is one of the requirement of a diesel engine. So in order to have proper functioning of this diesel engine, so the lubricant is circulated. So this is the lubricating oil tank through which a lubricating oil pump is going to supply this oil, lubricating oil, passing it through the oil filter, and this lubricating oil enters into the diesel engine for the various parts. And when it enters into the diesel engine to the various parts, as the engine is working at hot condition, so this oil becomes hot, and again this is taken out, and this oil is cooled in oil cooler. Again this cooled oil is returned to the lubricating tank. Same oil is again recirculated into the diesel engine. So this is how diesel power plant works. So main component of this diesel power plant is diesel engine, and which is connected to the generator, which converts this mechanical energy into electrical energy, and that is transmitted for various application, or it is supplied to the grid. So this is what is a diesel power plant, how this diesel power plant works. Now coming to the advantages and disadvantages of diesel power plant. So this diesel power plant requires very less space for cooling. So generally we used to have a diesel generator in our campus or anywhere. So that is nothing but it requires very less space. Then thermal efficiency is better than steam power plant of same size. So thermal efficiency of diesel engine power plant or diesel power plant is better compared to the thermal power plant. Then the overall cost is cheaper than that of the steam power plant of same size. So cost of diesel power plant is also less. Then disadvantages of diesel power plant are, first is cost of lubrication is very high. So as there are moving parts in this reciprocating parts in this diesel engine, therefore lubrication is very much essential factor, and which costs very high. Then maintenance charges are generally high, as the lubrication as well as the reciprocating parts are in this diesel engine, therefore the maintenance charges are high. Then plant can only generate small power, so this is not suitable for large power generation in megawatt and all. So this is feasible to very low power generation. Then the plant does not work satisfactorily under overload conditions for longer period. So if the load increases beyond the capacity, then this diesel power plant does not work in the overload conditions for longer duration. It can work for shorter duration, but for longer duration diesel power plant does not work satisfactorily under overload conditions. Then the plant has high running charges as the fuel is costly. So fuel used in this diesel power plant is diesel, and the cost of diesel is very high compared to the coal which is used in thermal power plant. So these are the few disadvantages of diesel power plant. Then coming to this gas turbine power plant. So this gas turbine power plant is a typical natural gas power plant which operates by propelling hot gas through a turbine. So hot gas is passed through the turbine in order to convert heat energy into mechanical energy. That is nothing but hot gases are first produced, and those gases are expanded into the turbine, and this turbine is connected to the generator to produce electrical energy. So turbines have very high specific power, which means that power they provide for massive, they are is relatively high. That is nothing but the amount of power produced to the weight of gas turbine is high. That is, the high power is produced as compared with the its self weight. So then the gas turbine plant, how it works, that we see. So very first in this gas turbine power plant, there are two major components known as compressor and gas turbine. So very first, the air is taken from atmosphere, passed through the filter, and then that air is compressed. So compressed air is passed into the combustion chamber. So in this combustion chamber, the oil is injected or fuel is injected and this fuel is burned in presence of compressed air, and this product of combustion, hot gases, are passed into the turbine. So these hot gases are at high pressure and high temperature, so already it is compressed, and when it comes into the turbine, so this hot gases are expanded into the gas turbine, and the product of combustion after expansion is exhausted to the atmosphere. So here when the gases are expanded into the turbine, so the heat energy is converted into mechanical work, and this shaft starts to rotate. So part of this energy or mechanical work is utilized by this compressor to compress the air, and extra amount of part of mechanical work is supplied to the alternator, or we call it as a generator. So this generator convert this mechanical work into electrical energy, and for starting of this gas turbine, it is necessary to have a starting motor. So this starting motor helps us to run this compressor to compress air, and as this power generation starts, that the hot gases come into the gas turbine, then the gas turbine itself starts to produce mechanical work. At that time this starting motor is switched off. So this starting motor is required at the initial stage when we start this gas turbine power plant. So here the compressor is going to compress air, and this compressed air is passed into the combustion chamber. In presence of compressed air, fuel is burned. So this is expanded in the gas turbine, where heat energy is converted into mechanical work, and that mechanical work is utilized to generate electrical energy by coupling or connecting this gas turbine with the alternator. So then classification of gas turbine power plant. So this gas turbine power plants are classified into two categories. Very first is open cycle gas turbine power plant, and second one is closed cycle gas turbine power plant. So what this open cycle gas turbine power plant is, just what we have seen is the open cycle. So open cycle is nothing but air is supplied into this compressor by filtering it, and then this air is supplied to the combustor or combustion chamber, and to which fuel is supplied. So the product of combustion is passed into the turbine, and that turbine converts heat energy into mechanical work, and the product of combustion is exhausted into the atmosphere. This is not reused, so that's why it is called as an open cycle. So this exhaust gases are sent into the atmosphere, so therefore it is called as a open cycle gas turbine. So the power generated in the turbine is connected to the generator or alternator, where the mechanical work is converted into electrical energy, and part of that mechanical work is used to run this compressor. So this is called as a open cycle gas turbine power plant. Then closed cycle gas turbine power plant. What this closed cycle gas turbine power plant is? Now here we can see the exhaust gases are passed into the compressor, and this compressor is going to compress these exhaust gases, and when these are supplied into the heat exchanger, so these gases are heated in this heat exchanger, not by means of a fuel burning of fuel into the heat exchanger. Somewhere fuel is burned and heat produced is brought to the heat exchanger, and hot gases exchange heat with this gas into the heat exchanger, and these gases are again passed into the turbine and expanded. So in high pressure turbine, then again these gases are passed into the low pressure turbine, and then these gases, after passing from low pressure turbine, are brought into the heat exchanger, where heat is rejected. That means the specific volume of gases is reduced. Again it is passed into the compressor. Again these gases are passed into the heat exchanger, where these gases are heated. Again the high pressure high temperature gases are passed into the turbine in order to expand and to produce mechanical work. So in high pressure turbine, first it is expanded, then it is expanded into the low pressure turbine, and those exhaust gases again are recirculated. Therefore this type of gas turbine power plant is known as a closed gas turbine power plant, because these gases which are circulated in the compressor and turbine are recirculated. Then coming to the advantages of gas turbine power plant. So very first advantage is they are small in size, weigh less, and have low initial cost per unit output. So that is, the power generation is cheaper in case of gas turbine power plant. Then they are easy to install within short period. So gas turbine power plant has got capacity, or one can install these gas turbine power plants in shorter time. Then they are quick starting and smooth running. As the rotary parts are involved, so vibration as well as noise is very less and can be started quickly. Then they offer flexibility by supplying electricity for power generation as well as by supplying compressed air for processes needs. That is nothing but such gas turbine power plants are helpful for producing electrical energy as well as for supplying compressed air to the various processes required in the industry. For various pneumatic operations, compressed air is also required. Sometimes the part of energy is used to run the compressor and remaining part of energy is used to produce electricity. But in some cases, complete energy produced in this gas turbine can be used to generate or to produce compressed air, which is required to run this system as well as to use it in the system or pneumatic systems. So therefore this is having flexibility. Then they are capable of using a range of liquid and gaseous fuels including synthetic fuels. So it can be here we can use liquid or gaseous fuels, but the solid fuels cannot be used in the gas turbine plants, that is open gas cycle, gas turbine power cycle, but it can be used in closed gas turbine power cycle. Then they are subjected to few environmental restrictions than other prime movers. So environmental restrictions or norms are subjected to few restrictions. That means the restrictions compared with the other power plant are less for this gas turbine power plant. Then water consumption is less compared to steam power plant. In case of steam power plant, steam is required to be produced by combustion of fuel into the boiler, so where the large quantity of water is required. But here in gas turbine power plant, steam is not used to run this primer or turbine, therefore amount of water required is less compared to the thermal power plant. Then disadvantage of gas power plant. So very first is, for starting purpose, a starting motor is required. In order to start the compressor or to have the compressed air or compressed gas, so it is necessary to start the compressor first. So in order to start compressor, so starting motor is required, or starting power or IC engine is required. Then second one is, starting is not simple as in case of other power plant. So as it requires the starting motor or IC engine to start, and it takes some time for starting, and it is difficult for this gas power plant to start initially. Then gas turbine plants have less vibrations, so it has got less vibration. This is one kind of advantage. Then high frequency noise from compressor is objectionable. So as the compressor is used in this gas turbine power plant, and high frequency noise is produced in the compressor, and that is objectionable by the occupants or by people residing surrounding this system. Then high temperature imposes severe restrictions on servicing condition. So as the gas turbine power plant works at high temperature, and due to high temperature ranges, there are certain restrictions or servicing conditions. Whenever we need to do the maintenance, high temperature of the gas is going to have the restriction over the maintenance activities, whereas overall efficiency is low, since 2/3 of power output is used for driving compressor. So 60% is used for driving the compressor and 30% is used to generate electricity, therefore the overall efficiency is less. Then blades of turbine require special cooling method because the gases are entering at very high temperature. Then the metals used for manufacturing of parts of this gas turbine power plant must be special metal alloys, as the blades as well as parts of this gas turbine power plant are exposed to the high temperature and high pressure. Then there are incompatibility with the solid fuels. So these gas turbine power plants cannot be operated by using the solid fuels just like coal and wood. Then hydroelectric power plant. What this hydroelectric power plant is? So in case of hydroelectric power plant, the water is stored into the reservoir which has got high potential energy, because this water is stored at very high altitude, and then the water is passed through the penstock or pipe to the turbine by converting the potential energy of water into kinetic energy, and this kinetic energy is converted into mechanical work in a water turbine and this mechanical energy is converted into electrical energy in a generator coupled to the turbine. So initially water is stored into the reservoir. It contains potential energy as it is stored at very high altitude. When water starts to flow, this potential energy gets converted into kinetic energy, and this kinetic energy of water gets converted into mechanical work in a turbine. And then this mechanical energy is converted into electrical energy when this turbine is connected to the generator or alternator, and this electrical energy is transmitted with the help of transmission lines wherever we need to use this electrical energy. So now we can see one example here. This is a dam, and in this dam water is stored in a reservoir. So this water is passed through this intake gate through a penstock. So this pipe which is known as a penstock. So then this water is passed into the turbine. When this kinetic energy of water, initially water which is stored at high altitude has got a potential energy. When it starts to flow through penstock, this potential energy gets converted into kinetic energy, and this water, when it is passed into the it makes the turbine blade to rotate, that is converting this kinetic energy into mechanical energy. So this mechanical energy is supplied to the generator, where this mechanical energy is converted into electrical energy, and this electrical energy is transmitted through transmission lines to the grid. So this water, after making this turbine to rotate, is passed into the river or draft tube into the river. So this is image, and again we have a line diagram for this. We have line diagram for hydroelectric power plant. We can see here this is a reservoir for water, and here is the dam. So this water is passed into this penstock through this gate. So here there is a wall to control or to regulate the flow rate of water. Then this is passed into this surge tank. So this surge tank is provided to bear the back pressure of this water, and this water is passed into this turbine through penstock. This is inlet wall. So whenever load increases or decreases, so with the decrease in the load, suddenly this wall is flow rate is reduced, and suddenly there may be a shock. So to absorb shocks, surge tanks are provided. So when this water comes into the turbine, so turbine blade starts to rotate, and this mechanical energy is supplied to the generator, electric generator, and this electric generator converts this mechanical energy into electrical energy, and this electrical energy is supplied through transformer to the grid, and the water which is passed into the turbine is discharged through this draft tube into the river. So this is how the hydroelectric power plant works. So in your examination, if you want to draw this diagram, helps, is better for you to draw in this in your examination. Then classification of hydroelectric power plant. So according to construction and working, we can classify this hydroelectric power plant broadly into two categories. So one is according to construction and working, another is depending on the capacity. So according to construction and working, very first type is impoundment or reservoir. So just what we have studied is impoundment or reservoir type of hydroelectric power plant. Then second one is diversion or runoff river. Then third one is pumped storage. Then second category of classification according to power generation. So depending on large hydropower, where the power generated is above 30 megawatt, it is the large hydropower. Then small hydropower, if the generating capacity is above 10 megawatt, 10 to 30, that is small. And micro hydropower plant, which is only of 100 kilowatt, not in megawatt. We can see here there is a dam, and water is stored, that is passed through the penstock. Just what we have studied is known as impoundment type of hydroelectric power plant. So where the water is stored into the reservoir. Then second one is a runoff river type of hydroelectric power plant. Runoff river type is nothing but, so the water is diverted from river, and this water is taken to the turbine. So water is not passed, or water is not stored into the reservoir. So the flowing water of river is diverted, and that water is passed through the turbine. So here there is no construction of dam and all. So that is known as a runoff river type hydroelectric power plant. So running river is trapped, and this flow is diverted through the turbine. Then third one is runoff. So this is not a runoff river, this is pumped. So this name is wrong. So pumped type of hydroelectric power plant. So here the water is pumped with the help of non-conventional energy sources such as wind energy. You can see here. So there are windmills which help us to pump water from lower level to the higher level in a reservoir. So this water which is stored into the reservoir is used whenever necessary, whenever required to produce electrical energy. So this reservoir or pumped type of hydroelectric power plant, here the water is pumped from a lower reservoir, and it is stored into the upper reservoir using non-conventional energy sources, that is wind or solar, whatsoever it is. And whenever we need continuous supply of electrical energy, then this water stored into the upper reservoir is passed through the turbine to produce electrical energy. So here we have pump as well as turbine. So pump helps us to store water at higher level, and turbine helps us to convert this energy of water stored into the upper reservoir into electrical energy. So this is how this pump type of hydroelectric power plant works. Then advantages of hydroelectric power plant. So very first advantage is hydroelectricity is renewable source of energy, which is non-polluting source of energy. Then hydroelectricity has operational flexibility. So it can take the sudden rise in the load, or it can adjust with the sudden decrease in the load. So hydroelectricity promotes guaranteed energy and price stability. So here the cost of fuel is going to be remain same, as in case of diesel power plant or in thermal power plant, the cost of coal as well as diesel is going to vary internationally. But here in hydroelectric power plant, the cost of stored water is not going to vary. So therefore the price is stable here. Then hydroelectricity contributes to storage of drinking water, reduces floods and droughts. So here, as in case of hydroelectric power plant, we are going to construct dam. So the water stored into the dam is used for generating electricity as well as for having drinking water, and this also reduces floods. As the reservoir has large capacity, therefore the sudden floods are reduced and the water is stored. Then if we have reservoir or sufficient quantity of water storage, then droughts can have lesser effect over the region. Then hydroelectricity increases stability and reliability of electricity systems. So it provides stability as well as reliability, because we have sufficient quantity of water stored, and from that we can extract continuous power generation. Therefore it is a reliable source of electrical energy. Then hydroelectricity helps us to fight climatic changes, greenhouse gases. So due to this hydroelectricity power generation, no greenhouse gases are produced, and environmental pollution is reduced. So hydroelectricity does not pollute air we breathe. So in case of thermal power plant or in diesel power plant, so air pollution takes place, but in hydroelectricity power generation, it is not going to pollute air which we breathe. Then hydroelectricity offers a significant contribution to development. So as the hydroelectricity power generation is established in a particular region, then there will be a development in that region, such as road, rail and other industrial areas are going to get developed in such a region. Then hydroelectricity means clean and cheap energy for today as well as for tomorrow. So it is non-polluting source of energy and helps us for the national growth, as well as it is cheap source of energy. There is nothing but another thing is the hydroelectricity is a fundamental instrument for sustainable development. Sustainable development in the sense we are going to achieve development with less environmental pollution or damages to environment. So we can call this hydroelectrical energy as a part of sustainable development. Then disadvantages of hydroelectric power plant. Very first is impact on aquatic life. So the life of fishes and all, as we are going to stop flowing water, so is going to get affected. Then a running water source must be damped. So here the running water has to be stopped and it is to be stored. This is one of the disadvantage. Then limited plant location. So we cannot construct hydroelectric power plant anywhere we want. So it should be a site where the potential energy we can achieve the head of water, that is it should have high altitude to store the water in this hydroelectric power plant. Then limited sites are suitable for plant construction. So all sites, even we have limited sites, but all the sites which we get with all requirements are not suitable for plant construction. Only few sites are suitable for construction of hydroelectric power plant. Then higher initial cost, as we are going to construct a dam, so construction of dam is costly, as well as land acquisition is also one of the issue in case of hydroelectric power plant. So therefore the cost of hydroelectric power plant is going to increase. Then carbon and methane emission. The water reservoir liberates carbon as well as methane emissions. Then susceptible to droughts. So as we are going to stop the running water, so the lower sides of the river are suffering from the droughts, as they are going to get less water from the river. Then flood risk. So in case suddenly if the dam gets damaged or breaks, then the risk of flood is also going to exist. So it may get damaged because of any reason, because of heavy rain, or it may be because of earthquake, whatsoever may be, it may be any other natural calamity. So there is a chance of flood. So that is one of the disadvantages of hydroelectric power plant. Then site selection for hydroelectric power plant. So which kind of site has to be selected? So very first is there must be sufficient quantity of water available. Then there should be a proper water storage site, or if there is only plain land, we cannot store water, so there must be a hilly section, or there must be a natural naturally available sites where the easy site or easy construction of dam as well as storage of water must be available. Then waterhead. So wherever we are going to construct dam, that should be at higher altitude than the lower side of river, so which has got high head. So if there is a high head, then high potential energy of water that can be converted into electrical energy. Distance from load center. So distance from load center is nothing but wherever we generate electricity with the help of hydroelectric power plant, that should be very close to the load center, in the sense industrial area or the cities, so that the transmission losses for electrical energy generated will be less. So that means the distance from load center to the hydro power plant should be very small. Then transportation facilities should be there. So if there is no transportation facility, then it is very difficult to construct the dams as well as to install the hydroelectric power plant. Then availability of land. So land should be available in cheap. So as I told you, land acquisition is one of the issue which increases the cost of hydroelectric power plant. The lands of a private owner has to be paid, and that increases the cost of hydroelectric power plant. If the non-fertile lands are there, then the lands which are available can be acquired by paying less money, and that increases that reduces the cost of hydroelectric power plant. So this is how now we have completed this hydroelectric power plant. So we are left with nuclear power plant that we discuss into the next class. Thank you.